Hey y'all, welcome back. Today we are going to continue talking about angle measurement, but we're going to be talking about angles a little differently. So last time we learned how to sketch angle measures in standard position, and we learned how to identify coterminal angles. But in all the problems that we looked at, every single one was measured using the same units, degrees. And today we're going to learn all about a different unit of measurement in regards to angle measures, and that unit of measurement is called a radian. So when you're measuring lengths, for instance, there are many ways you can measure length, many different units of measurements that you can use. You might use meters, you might use miles, you might use feet or inches or centimeters, or whatever is useful for the context of the problem you're dealing with. Angle measures can be measured in different units as well. Degrees is the one you're probably most familiar with. But there's another one, there's radians. And today we're going to learn what a radian is and how to measure angles using radians. You're going to think at first that this is just kind of overcomplicate, the whole process of understanding what angle you're working with. But over time, I think you'll learn to appreciate the value of this other unit of measurement. And especially next year in calculus, you're going to be using radians way more often than degrees. So let's talk about what a radian is. Okay, so we've got a little definition up here. It says the measure of an angle is determined by the amount of rotation from the initial side to the terminal side. That's what we talked about last time, right? One unit of measurement that you're used to using is degrees. There are 360 degrees in one full revolution. However, we're going to talk about radians today. Now, instead of being 360 degrees in one revolution, when we're talking about radians, there's exactly 2 pi radians in one revolution. So pi being roughly 3.14, 2 pi being roughly 6.28, not exactly, but pretty close. So there's about 6.28 radians in one revolution, whereas there's 360 degrees in one revolution. So let me give you a little bit more specific definition of what a radian is. A radian is the measure of a circle's central angle that intercepts an arc equal in length to the radius of the circle. Now I know, you hear that and it really is meaningless when you just hear the definition, without any sort of diagram or indication of what are we really talking about here. So let's try to sketch this out. I think it's way easier to describe what a radian is, how big it is, with a diagram. So what I'm going to do is let's clarify what I mean by a radian with a diagram. So let's say you have a circle. Okay, so I'm going to sketch out a little circle here, or not a little one, but a decent sized circle. Let's see. Okay, that looks pretty good. So here's a circle, right? And as you can see on that circle has a radius. Every circle has a radius. What I might want to do is draw the center first to make this look a little nicer, make sure I'm actually getting it in the right spot. Okay, that looks pretty good. Okay, so we know this point is in the center, and the radius, hopefully you're aware, is the distance from the center to the circumference. So we'll call this a radius. Now, let's say we want to draw an arc. So an arc is like a portion of this circumference, okay? Now let's say I draw another radius in such a way that, so here's another radius, right? Just type that in there, here's another radius. Let's say we draw this in such a way that this distance, we'll call it r, okay? We'll just say that this equals r. We're not actually going to measure it. We're just going to use r as an unknown. We don't need to know exactly what it is. We'll just say it's exactly r. If we sketch this in such a way to where this arc, so like from here to here, if we were to take a string and measure this little portion of the circumference here, if this arc is equal to the radius, if the arc length is equal to the radius, if you set up your little slice of pie like this, then this angle measure right here is exactly 1 radian. Okay, so a radian is an angle measure where the intercepted arc here is the same length as the radius. So you can see real quick, I mean, this is a lot bigger than a degree, right? A degree is very small. There's 360 degrees in one revolution, so its degree is like tiny, tiny, tiny little angle. A radian is much bigger. Now, if I were to take this, slice of pie and just sort of copy and paste it over and over again, what you're going to find is that there are a little bit more than 3 radians. So here's another radian, but it doesn't quite go to that 180 degree mark. Okay, it's going to be a little bit shy of that. So you need like a little extra here. There's like a little extra sliver there. If I were to draw that, 180 degrees, like if this was just a straight segment. Now, you might be aware of a very special number that's a little bit more than 3, and it's about 0.14 right here. In fact, there are exactly pi units in a semicircle. I'm sorry, let me rephrase that. There's exactly pi radians for half of a revolution. It's a better way to say that. So if I keep going, you'll see that you're going to be able to squeeze in, and I'm just estimating here, but what you'll find is if you actually do this correctly, there's going to be like a little left over in here, okay? So there you see we've got 6 radians, and then you've got about 0.28 here, okay? So a little extra. And so what I was talking about before is that there are exactly 2 pi radians in a revolution, where 2 pi is approximately 6.28, right? So you can kind of see that visually here. So hopefully you're starting to get a feel for how big a radian is. Now usually we will write angle measures in radians in terms of pi. So it'll be pretty rare, although it'll pop up here and there. I won't say, hey, sketch out 2 radians very frequently. Instead, what I'll ask is, sketch out pi over 4 radians or pi over 3 radians or something like that. A third of a pi of radians. And so, and we'll get into how you sketch all that out, but just know that that's kind of where we're going. So I know it's written above, but I think it's worth reiterating here. Let me make this a little bigger so it's easier to see for you guys. There are exactly, oh, come on, let's get some red in there. There are exactly 2 pi units. Oh, pi, I don't think I have, oh, let me see if I can find one. Yeah, there it is, okay. There are exactly 2 pi radians in one revolution. So what does that mean? That means if you want to say convert between radians and degrees, we know, let's put that down here. We know that 360 degrees is equivalent to 2 pi radians. So I'm going to draw a little, I'm going to write that over here as well. 360 degrees, how am I going to get that in there? Well, I think, I'll come back to that. 360 degrees is equal to 2 pi radians. So this conversion, it's similar to like thinking like there are 12 inches in 1 foot. Well, there's 360 degrees in 2 pi radians. It's 1 full revolution. So let's get a little bit more detailed about how we're going to convert units. So since we know that there are 2 pi radians in a single revolution, and that's equivalent to 360 degrees, we can use that information to convert back and forth. One ratio that you can use to solve for this, regardless of which way you're going, is that 2 pi, and we'll reduce this in a minute, but since 2 pi is equivalent to, or 2 pi radians, how am I going to put a space in there? I'm not really sure how I'm going to do that. Well, anyway, so 2 pi radians is equivalent to 360 degrees. So depending on what you're given, like let's say you want to go from radians to degrees, you're going to set that equal to another fraction where you plug in your radians on top, and you're going to plug in, and your unknown is going to be the degrees at the bottom. So you can always set up a ratio like this and cross multiply and solve, and that's how we're going to do some of these, but there's an easier way to do some of them as well. We'll go through and do some examples. One quick thing here, we can actually reduce this. If 2 pi radians is equivalent to 360 degrees, then pi radians should be equivalent to 180. And we can get a little simpler fraction there. So how many radians is 90 degrees? Okay, so let's think about that. If 2 pi is the same as 360 degrees, then what's a fourth of that? So 90 degrees is a fourth of 360. So what is a fourth of 2 pi? Okay, so 2 pi, and we want a fourth of that, is going to be equal to pi over 2. All right, so what I'm trying to say here is that there are pi over 2 radians, that is equal to 90 degrees. They are the same. So like if I ask you to sketch out 90 degrees, you would set up your axes like this. You would draw your initial side over here, your terminal side should go straight up, and then you do your little rotation notation like that, right? So that would be 90 degrees. Now if I ask you to sketch pi over 2 radians, that would be equivalent, okay? Recall that 2 pi is 1 full revolution. So if I divide that into 4 pieces, okay, I get 90 degrees. 180 is half of 360. So half of 2 pi is pi. So the way I'm calculating that is I say, okay, well, 2 pi, I think I'll do is just copy and paste that pi because I'm going to need it a lot. Divided by 2 is just going to be pi. Radians. Really want a space in there. I'm not sure why it's not letting me do that. Maybe, you know what I'll do? I'll just do a separate little text box here. Stick with me here. Sorry, this is taking a while. Okay, so yeah, 180. Now, same kind of thing. I don't think we need to sketch all these out, but you can kind of see what that's going to look like, and it kind of makes sense. If you know that 2 pi is going to be 1 full revolution. Oh, come on, let's get a straight line there. There we go. If 2 pi is a full revolution like this, then half of that would be 1 pi, and we know that's 180 degrees. Actually, I can just kind of draw like that. Now 270 we know is going to be at, along the negative y-axis. So if I'm going to sketch that angle out, I'm going to do it like this. The angle measure is going to be here. And I want to know how many radians that is. Well, that's 3/4 of 2 pi, right? 3/4 of 2 pi radians. So I might go here and I say, okay, 3/4 of 2 pi, 3/4 of means we times, we multiply here. Where's my little multiplication symbol? Do I not have one? Oh, come on. Let's see. I'm gonna grab one from this other website. This is where I'm finding all these little symbols. So 3/4 of 2 pi. So 3 times 2 is 6. 6 divided. So let's just not do too much in my head here. 3 times 2 is 6, so that'd be 6 pi over 4, which would equal 3 pi over 2. Oh, and I copied the multiplication, now I lost the pi. There we go. Okay, so we get 3 pi over 2. So 3 pi over 2 radians is going to be equivalent to 270 degrees. Right? It's 3/4 of the 2 pi. All right, so when you're starting to get a feel for how where all these radian measures go in terms of once we start sketching out the actual angles, what I like to do is just have kind of a little cheat sheet here where in degrees I know 0's here, then we have 90, then we have 180, right? And these are all in degrees. 270, and then if we go all the way around, we end up back at 360. And if we do the same thing but in radians, this is still 0. We're still going to start at 0. Up here will be pi over 2 radians. Over here will be pi radians. Down here will be 3 pi over 2 radians. And then over here we've got 2 pi radians. So we've got about 6.28, over here 3.14, and then kind of halfway in between those. So this kind of will, hopefully this helps when we start getting to actual diagrams. So before we start sketching out angle measures, we do want to be able to convert back and forth between radians and degrees. Now, if your radians are in terms of pi, which most of the time they will be, then there's actually a real easy trick how you can convert this from radians to degrees, because we know that, here I'll do text so I can do some spaces in here. We know that 180 degrees, and I'm going to do this little trick here, 180 degrees is equivalent, let's get rid of that, there we go, is equal to pi, do I still have it? Nope, I didn't like that at all. So let's grab it back from over here. Bear with me, y'all. One of these days I'll know what I'm doing. All right, so is equal to pi radians, right? So we know that should be the conversion that you just have memorized. Pi radians is the same as 180 degrees. It's about 3.14 radians. So since we know that to be true, if we're converting from radians to degrees and we see a pi somewhere in the radians, and most of the time there will be pi that'll be written in terms of pi, we can just take that pi and replace it with 180. So I'll say if the radians are written in terms of pi, replace pi with 180 and simplify. That is not 180. So if I want to convert this to degrees, it's pretty easy. You're just going to say that it equals 2, I lost my multiplication symbol. You know what? I'll just use parentheses. Times 180 instead of pi divided by 3. And then you can just simplify that. If you're not sure what it is, pull out the calculator, and just evaluate it, right? 2 times 180, well, that'd be 360, divided by, I didn't need a calculator for that, come on, Mr. Schuler. Divided by 3 is 120. So we know that 2 pi over 3 radians is equivalent to 120 degrees. Okay, so pretty simple. There's not really a lot to it. Now, unfortunately, it's not always going to be in terms of pi, so you can't always use that little trick. If it's not in terms of pi, then you do need to set up a proportion and solve the proportion. So that proportion that I'm talking about is this one that we set up here. Let me get rid of the calculator so you can see what I'm talking about. In fact, I'm just going to copy this whole thing and replace it down here. So let's say I have 1 radian. Just to visualize that, 1 radian's like, right, the terminal size can be right here. And if you're eyeballing it, what does that look like? It looks like it's roughly 60 degrees, maybe 70, maybe 50, somewhere in that general vicinity. So when we convert, we should expect to get a number somewhere around there. And it's a good idea to kind of eyeball it first, so you have like a mental idea of like, okay, I know the answer is going to be around whatever. And then when you go to calculate it, if it's way off, then maybe that should be a red flag. But if it's close, then you should have some, pardon the pun, degree of confidence that you're right. So anyway, we're going to go ahead and set up this ratio. So pi over 180, that's going to be sort of our baseline here. Where is it? Oh, there it is. And okay, so we're converting 1 radian to degrees. So I'm going to put 1 here, and I'm going to put the degrees. That's my x. I don't know what it is. That's what I'm trying to find. So when you try to solve a proportion, the way you handle that is through cross multiplication. Okay, we're using a property called the cross products property. So the cross products property says when you have 2 equal fractions like this, you can multiply Like in this case, I can multiply 1 times 80, 1 times 80 equals pi times x. Oh, I just want the pi. Just give me the pi. Pi times x. Okay, so how do I solve for x? Well, I'm just going to divide by pi here. pretty easy. So 1 times 180 is 180, and so x is going to be equal to 180 divided by pi. And I'm going to leave it like that. It's irrational. I don't need to know exactly what it is. If you put this in the calculator, if you're really just wondering, hey, am I getting it right? I know it's supposed to be around 60 degrees maybe, but I'm not really sure. Let's double check. 180 divided by pi. Oh, where'd my calculator go? There it is. 180 divided by pi is about 57. So that, and this is just a, kind of a rough sketch. That looks like it could be about 57 degrees. It looks pretty good. So yeah, so what we get, you can either write it exactly like this, or be comfortable putting it in your calculator, and you can estimate it. So x, you could say, is approximately. Let's get rid of that calculator so you can see what I'm. Oh wait, no, you can't see what I'm writing. Okay, good. Is approximately 57 point. We'll say 3, just to kind of make it simple. Degrees. So. I might ask for the exact answer. I might ask for a rounded answer. You want to be comfortable with both. So that's how you convert from radians to degrees. So if there's a pi in there, just replace it with 180. If there's not a pi in there, you can use this proportional, you can use the cross products property to solve this proportion. Now you can always use this cross products property, set up a proportion, even if there's pi in there, right? Like I could have put 2 pi over 3 up here where the 1 is and then solved that. But it's just easier. It's so much easier to just replace this pi with 180. I mean, I can't stress how much easier that is. Now, unfortunately, going backwards, we're not going to have like an easy thing like that where we can sort of cheat our way to victory here. So let's talk about converting from degrees to radians rather than from radians to degrees. And you know what? Let's get rid of this calculator temporarily. Okay, so let's go from degrees to radians. So our setup is going to be very similar. Okay, we're going to use this proportion. Okay, so I'm going to go back and steal this guy right here. Let's see, I'm just going to copy and paste it. Bring it down here. Okay, so that's the proportion I'm going to use because we know that 180 degrees is equal to pi radians. And what we're trying to do is go from degrees to radians. So you're going to solve it similarly to this one up here. Up here we put the 1 radians where I had radians and x where degrees was because I was trying to find degrees. And here it's reversed, right? So I know the degrees is 64, but my radians, that's my unknown. Okay, so the way we're going to solve it though is identical. We're still going to use the cross products property to isolate x here. So I will multiply x times 180, and I'll multiply 64 times pi. And that will leave me with, let's see, 180x equals 64 pi. And then to solve for x, I just need to divide both sides by 180. So I get x equals 64 pi divided by 180. And that's good. We can reduce that. Let me show you a little trick in the calculator, how if you're just like in a rush and you want to reduce, let me show you how to do reductions in the calculator. So if you don't already know, you can put fractions in here. You hit alpha, y equals, and then just pick the first option and it'll set up a little fraction for you. And so I'm trying to reduce 64 over 180. I know I can look at that and say, okay, I can divide them by 2. Can I divide it by 4? I'm not really sure, but if I just put the fraction in here, it will reduce automatically. You don't even have to do anything. You just type it in, hit enter, and then there you go. So this can be reduced to, let's get rid of this now, 16 over 45 is what it said. So let's go ahead and write this reduced. So 16, what was it again? Let's pull that back up. 16 over 45. So 16 pi over 45 radians. So this would be equivalent to 64 degrees. 64 degrees, you know, like I'm not asking you to sketch this quite yet, although we will get into sketches. But if you were to sketch this, 64 degrees is definitely closer to 90 than it is to 0. So we are in quadrant 1, but we should be somewhere over here, is right here. So this would be either 64 degrees, or you could say it's 16 pi over 45 radians. All right, let's move on. Yeah, let's talk about how to sketch these angles in standard position. So you're going to sketch them exactly how you would in degrees. Now, at first, you know, as you're starting to get used to these radians, and you will get used to radians, trust me, because we're going to kind of transition to where eventually we're only going to be using radians. I know it's going to be kind of frustrating at first, but you got to trust me on this one. What we're going to be doing later in the year is going to be easier if we're working with radians versus degrees. You're just going to have to trust me on that one, like I said. So how do we sketch these out? Well, you sketch them out just like you would a normal angle. So for 2 pi, we know that is 1 full revolution. So we just go like 1 full revolution, and it looks like our ray actually ends up where we started. Pi, we said was half of that, right? That's 180 degrees. So it should look like this. Pi over 2, we said was 90 degrees. Now, if you're ever a little unsure, you could always convert. I do want you to eventually get to a point where you don't have to convert, but let's just say, okay, 3 pi over 2, I just don't really, you know, it's hard for me to figure out where that should go. We can just, you know, substitute, you know, scratch that out, you know, replace that with 180 and do 3 times 180 divided by 2. 180 divided by 2 would be 90, times 3 is 270. So if you know where 270 is, 270 degrees, then you can find where that terminal side is going to be. It's just going to be right down here in the positive or the negative y-axis. And the angle measure is going to be right here. So these are kind of the simple ones. These are all sort of your extremes. And so these will help you to figure out where the rest of the angle measure should go. So let me scroll back up just temporarily and kind of look back at this. In fact, I really like this diagram. I don't want to have to redo it, so I'm going to just steal it. I'm going to copy it. Copying, stealing, you know, what's the difference? All right. Yeah, never mind. I'm going to get myself in trouble here. Okay, so, well, that's a little too big. I wish I could make it smaller. But you guys get the point here. Point being that if you want to have a good reference for, where these sort of key angle measures are to help you figure out where the rest of these are. So let me show you 2 different ways I'm just going to delete that. That's not as helpful as I thought it would be. It's too big. 2 different ways on how you can figure out where the terminal side should go. So like, for instance, pi over 6. Okay. Pi over 6, we can convert that. And so this is sort of the long way to do it. You eventually will know where all these go a lot easier. But for right now, you could just say, okay, 180 divided by 6. What is 180 divided by 6? I don't know. Is that 30? Yeah, it's 18 over 6 should be 3. So yeah, it should be 30 degrees. So we know, I'll put the degree here just to make it more obvious. So we know that that's where 30 degrees should go. We know 30 degrees is right here. Now you should not have to convert necessarily. It can be a little tricky because we're talking about fractions here. And then pi just kind of throws a wrench into the mix. But let's say I don't want to try to convert. I mean, I could. We definitely could, but I kind of want to avoid it. So let's look at 5 pi over 4. We'll come back to this -1 in a sec. So 5 pi over 4. One little trick you can use to kind of figure out where the terminal side of a radian measured angle should go is let me label these. So here's 0. We know this is pi over 2. We know this is pi. And then 3 pi over 2. And then 2 pi. So another way you can kind of think about this is instead of fractions, think about decimals, okay? So like 2 pi, well, it's just 2 pi. Nothing really to say there. But half pi, you could say is like, okay, well, that's like 0.5 pi, right? There's half of a pi. Pi is just like 1 pi, right? And then 3 halves, 3 over 2 is 1.5. So this is like 1.5 pi. I don't know why this is like kind of glitching on me. But anyway, so you got the 0.5, 1, 1.52, et cetera, et cetera. So to figure out where it should go, just look at this fraction, okay? And figure out, okay, what is that as a decimal? 5 over 4 is 1.25. So if I think about it as a decimal, sometimes it's easier to visualize where that should go. And this is bigger than 1, so it's going to be more than 1, but it's less than 1.5. In fact, it's exactly halfway between it, right? 1.25 is halfway between 1 and 1.5, so I know my terminal side is going to be right here. If you were to have converted to degrees, you would have found it's in the same place. Okay, so sometimes it's easier to look at those decimals. And I'm not going to say, hey, you have to do it this way or you have to do it that way. They're just two different ways of trying to figure that out. Now, if you're good with fractions, like let's look at this negative 1/7 pi. Okay, so now we're negative, so this is going to be 0. This is going to be negative pi over 2. Let's make that look good, jeez. And then negative pi, so like if my terminal side were rotating in a clockwise manner, this would be the angle measures I would pass through. Negative 3 pi over 2, and then all the way to negative 2 pi. So if it's negative pi over 7, you want to think, okay, well, what does that fall in between? What does 1/7 fall in between? Does it fall in between 0 and 1/2, 1/2 and 1, 1 and 1.5, or 1.5 and 2? So 1/7 is in between 0 and 1/2. So it's going to be somewhere like right here. Now, if that makes you really uncomfortable, if you don't like fractions, you could convert to a decimal and approach it like we did this one over here. Or you could always just plug in 180 and figure out, the degree equivalent. Whatever is easier for you. Now let's look at 6 pi. Let's get rid of this calculator. Okay, 6 pi. Oh, get out of here, calculator. Okay, so 6 pi. What I would say, let's count pi's. We're going to revolve, starting at the initial side, and just kind of keep track of how many pi's we pass through. So like here is 1 pi, 2 pi, that's 1 full revolution, 3 pi, 4 pi, ew. Let's try that one again. 4 pi, looks like that, and then 5 pi, and then finally 6 pi. So it looks like it's a total of 3 revolutions, which makes sense because if 1 revolution is 2 pi, multiply that by 3 and you get 6 pi. So here are some examples. It'll take some practice to kind of get used to it. You can either, you can take any of these strategies as far as like plugging in 180 or looking at the decimal or looking at the fraction. Eventually, you're going to memorize where some of these more common angles are in radians. We're not quite there yet. We're just kind of getting used to what a radian is. But for right now, as you're sketching these angle measures, you can choose to take any of those strategies to get there. When we go through the homework, I'll probably just interchange the strategies just so you can see different examples of how you use them. Okay, one last thing, and that's it for today. So remember those coterminal angles where you had angle measures that had the same terminal side? Well, I'm going to ask you that exact same question, but in terms of radians rather than degrees. So when we were in degrees, what we did was we either added or subtracted 360 degrees from the given angle to find coterminal angles. Well, we're going to do the exact same thing here, except instead of adding or subtracting 360, we are going to add or subtract 2 pi radians. Now, it is a little trickier here because we're dealing with irrationals and we're dealing with fractions. So you're going to have to kind of be on your fraction, you're going to have to get your fraction game up. But that's just how we're going to find these. So let's say, pi over 3, We'll do the plug-in 180 trick for this first one. So we'll just say 180 divided by 3 is 60. So this is going to be 60 degrees. So 60 degrees is roughly right here. This is the angle measure in question. Okay, so we're trying to find angle measures that are coterminal of that. One would be like if we were to do a full revolution and then do the 60, right? Now, you could convert to degrees, find the coterminal angles, and then convert back, but that's a lot of extra work than you really need to do here. As long as you're okay adding fractions, and you really should be at this point, it's way easier to just find it by adding or subtracting 2 pi. So let's say pi over 3 plus 2 pi. Where'd my pi button go? There it is. Equals, okay, so let's talk through how we're going to add these. To add fractions, you need to find a common denominator, which in this case would be 3. So we'd have pi over 3 plus 6 pi over, that's not a plus, plus 6 pi over 3. Okay, and now we can just add. So 1 pi plus 6 pi is 7 pi over 3. Let's clean this up a little bit. Here we go. Equals 7 pi over 3. So this would be a positive coterminal angle. Now to get a negative coterminal angle, instead of subtracting, whoa, what happened there? I lost it. That's weird. I've never seen that before. All right, well, let me go ahead and retype that in there. Sorry about that. Waste your time here. 7 pi over 3. Okay, strange. There we go. So that's a positive one. That would be this blue one. In fact, let me go ahead and just like, you know what, let's put that box in blue so you can kind of see what's going on there. The other one, you know, a negative one would be if we start at the initial side and we rotated clockwise. So if we were to, oh, that's blue. Let's do green. If we do this one right here. Okay, so we're rotating clockwise, and to get to locate that angle measure, we are going to subtract 2 pi instead of add 2 pi. So what I'm going to do here is actually going to, so I don't have to retype all this stuff, I'm going to do a little tricky thing here, and I'm going to, why is it highlighting all of that? I don't need all of that. Okay, now just, I don't know what just happened here. See, I'm trying to save myself time, and I just made more work for myself. Serves me right, I guess. Okay, let's try that again. I guess we're just going to type it. So we're going to start with pi over 3. Where's my pi? There we go. So pi over 3 minus 2 pi. And to subtract fractions, you approach it the same way you add fractions, which is to say we are going to find a common denominator. So we've got pi over 3 minus 6 pi over 3. So 1 minus 6 is negative 5. So we should have negative 5 pi over 3. You know what? I lost my blue. I just realized I lost my blue rectangle over here. So let's highlight that one in blue, highlight this one in green so you can match this up with the diagram. And there you go. So we've got one positive angle measure and one negative angle measure, both in radians, that are coterminal to pi over 3. Okay, 11 pi over 17. So what I'm going to do here, I'm going to take a different, on this other one, I substituted 180 to kind of get an idea of where that terminal side should be. And I did 180 divided by 3. And that's a pretty easy calculation to do mentally. 11 times 180 over 17, that's going to be a little trickier. I know you could use a calculator, but what I want to do is I want to just take a look at this fraction. Okay, 11 over 17. That's less than 1. Let me ask you this, though. Is it more than a half? So, like, remember, half pi is right here. So half pi is here, and then pi is here. Right? I'm not even going to go further because I know this number to be less than 1. 11 smaller than 17. So what's half of 17? Well, half of 16 would be 8. Half of 18 would be 9. So it would be like 8.5. So 11 is more than that. So 11 over 17 is more than a half. So that's going to put our terminal side in quadrant 2. If you're not sure, you always, as always, you could double check yourself in the calculator. Okay, 11 over 17 is about 0.64, right? So it's more than half, right? It's more than 0.5. So it's just a little bit more. So it probably needs to be a little closer to the y-axis, but don't worry about it. So the angle measure that I have right now, the 11 pi over 17, is this one. And to find the coterminal angles, I'm going to do the same thing that I did with the pi over 3. Okay, so what I'm going to do here is I will add 2 pi. So we got 11 pi over 17 plus 2 pi. And when I do that, what I'm really going to get here is I'm going to, like, here's 11 pi over 17 plus a whole revolution is going to put me here. Okay, so that'll give me another angle which has the same terminal side. All right, and I'm going to find my common denominator here, which is 17. 2 times 17 is going to be 34, so that'd be 34 pi over 17. 34 plus 11 is going to be 45. Does that now 17 is prime, so we don't have to worry about reducing. Oh, whoa. 45 pi over 17. There we go. And let's go ahead and box that. And I'm going to box that in blue just so you can see visually, which angle measure that kind of matches up to. And then finally, we want a negative angle measure, right? It's at, the directions here say one positive and one negative coterminal angle. So to get the negative one, I'm going to start at the initial side and go clockwise until I hit that terminal side. So that's the one I really want. There are other ones, like if you continue to subtract 2 pi, but you don't really need to do that. Let's see, is this going to work? Yeah, okay, so I'm going to copy and paste that. So instead of adding 2 pi, I need to subtract 2 pi. And so I've got 11 pi over 17 minus 34 pi over 17. 11 minus 34. Well, when you subtract a bigger number from a smaller number, I've noticed a little trick you can do here is to make that computation a little easier to do mentally. Just reverse it. What's 34 minus 11? And then slap on a negative, okay? So 34 minus 11 is 23. So 23 pi, I lost my pi in my clipboard. 23 pi over 17, but it's negative because we're subtracting a bigger number from a smaller number. And that's going to be my green one. Okay, so just to kind of recap here, today we talked about radians as an alternate unit of measurement when we're talking about measuring angle measures. The amount of rotation that a ray does. We went over how to convert radians to degrees and vice versa. We learned how to sketch an angle measure using radians. And now we're looking at how to find coterminal angles in radians. So that's it for today. Y'all have a great day, and I'll see you next time.